Good morning, class. Welcome back to grade 6 mathematics. How are you all doing today? Let's discuss about some special numbers and words today. So you see these words or numbers given here. The first one, what is that word? Mom. See the letters. Can you try reading it backwards? You can read the exact same word backwards, right? Now the next phrase, Madam, I'm Adam. See the letters. Can you try reading this backwards? See, you have the same letters towards the left as well. So you can read the same exact phrase. Now the last one, you can see the number 1991. See the digits of it. Can you try reading it backwards? You can read the exact same number, right? So these kind of words or groups of letters or numbers which you can read the same forward and backward. They are called palindromes. So a palindrome is any group of letters or numbers that reads the same forward or backward. Now we are going to learn how we can form palindromes using numbers. You have an example here. This is from your textbook. You see this 2-digit number here, 48. Which are the digits? 4 and 8. Is it the same if you read it backwards? No. It reads 84 if you read it backwards. So this number 48 is not a palindrome. We are going to try to form a palindrome using the number 48. Let's see the steps. The first thing you have to do, just reverse the digits. That is, 48 becomes 84. The next step is to add 48 and 84. What do you get? When you add 48 and 84, you get, see, in the ones place you have 4 ones and 8 ones. So 8 plus 4, it is 12. I carry over to the tens place. Here 8 tens plus 4 tens is equal to 12 tens plus 1, we have 13 tens. So what is the sum? This is equal to 132. See the digits? 1, 3, 2. Try reading it backwards. It is 2, 3, 1. Is it the same number? No. So this number 132 is also not a palindrome. Now let's do the reversing once again. Here, reversing the digits, this becomes 231. Let's add 231 to 132. So that becomes 132 plus 231. And the sum is equal to 2 plus 1, 3, 3 plus 3, 6 and 2 plus 1, 3. The sum is 363. The digits are 3, 6, 3. Try reading it backwards. 3, 6, 3. The same number 363. So the number can be read the same forward or backward. So here we got a palindrome. So from the 2-digit number 48, we obtained a 3-digit palindrome. So this way you can form many different palindromes using 2-digit or 3-digit numbers or any digit numbers. So there is one more example given in your textbook. You are asked to find a palindrome using the number 98. Try it yourself. 98 is not a palindrome. So you just reverse the digit, add the two numbers, then see if the obtained number is a palindrome. If not, reverse the digits, do the sum, keep repeating until you get a palindrome from 98. Then see number of additions you did to get a palindrome from 98, and you have to write the number name for the palindrome thus obtained in the Indian system of numeration as well as international system of numeration. Then you also have to find out the biggest and smallest palindromic numbers having 9 digits. So these questions you can do as an activity in your notebook. Now we'll see a quick method for multiplying numbers by 11. We have an example given here. 34 into 11. How do you usually do this multiplication? You would write the numbers in proper columns first. That is 34 into 11 written like this. Then you will do the multiplication starting from the ones. So here 1 4s are 4, 1 3s are 3, 1 4s are 4, 1 3s are 3. So the sum is 4, 7, 3. This is how you usually multiply numbers. So the number obtained is 374. What if you can obtain the product of multiplying by 11 without actually multiplying the numbers? See, when you multiply here by 11, the ones digit of the multiplicand remains the same in the product. And here in this example, in this case, the tens digit of the multiplicand becomes the hundreds digit in the product. And the sum of the digits of the multiplicand, that is 3 plus 4. That becomes the tens digit. So I'll show you once again. Here in this multiplication, you have to write the ones digit as it is, add the two digits of the number, that is 3 plus 4, that is 7, then write the tens digit as it is. See, and the product is the same. So this is a quick way to multiply a number using 11. I'll show you one more example. Here you have 432 into 11. So if you go by the same way as in the previous case, let's see how we can write the product. So the ones digit should be written just like it is. So we have written that like that. Now 3 plus 2, 5, 4 plus 3, 7. Now here we are writing 4. So here the product is 4752. Let's do a checking. Let's multiply 432 by 11. That is 2 here, 3 here, 4 here. Then 2 here, 3 here, 4 here. And the sum is 4752 itself. So without actually multiplying, we obtain the answer in an easy way. So you can use this trick to make your calculations faster. I'll give you one question to solve here in this class. Please take down this question. Find 1234 into 11. I'll give you 1 minute to solve this. So please pause this video, finish this activity and come back. Hope you have done that. That was easy, right? So let's see how we can write the product without actually even multiplying. So here you have to write 4 as it is. Then take the sum of 3 and 4, that is 7. Now take the sum of 2 and 3, that is 5. Now take the sum of 1 and 2, it is 3. Then write 1 as it is. So the product will be 13,574. If needed, you can recheck this answer by properly multiplying. So this is one easy method to multiply numbers with 11. So I hope you like this trick. So let's see the box given us maths around us. There is a question given there. An assistant in a medical laboratory was studying 2 blood samples. The first sample contained 57,489 blood cells. The second sample contained 12,935 more blood cells than the first one. Round off the number of blood cells to the nearest 10,000 in the second sample. So what you have to do? You are given the number of blood cells in 2 blood samples. The first sample contains 57,489 blood cells, whereas in the second sample, the number of blood cells is 12,935 more than that in the first sample. So how do we find out the number of blood cells in the second sample? We can just add this 12,935 to 57,489 to get the number of blood cells in the second sample. So this will be the actual value. You are asked to find out an estimate value. You have to round off the number of blood cells to the nearest 10,000s. That is the number of blood cells in the second sample to the nearest 10,000s. So how do we find out the estimated sum of an addition? You have to round off both the addends, then find the estimated sum, right? So since they have asked us to round off to the nearest 10,000s, let's round off each of these numbers here to the nearest 10,000s. So the number 57,489 rounded off to the nearest 10,000s becomes 60,000 and the number 12,935 rounded off to the nearest 10,000s becomes 10,000. And hence the estimated number of blood cells in the second sample is equal to 60,000 plus 10,000, that is equal to 70,000 blood cells. This is an estimated value or approximate value or number of blood cells in the second sample. It is not the actual value but close to the actual value. So I hope this is clear to you. Now let's have a quick recap of the main concepts that we learned in this chapter. So first we learned about the different systems of enumerations. So in the Indian system of enumeration, the ones period alone consists of 3 places and the remaining periods have only 2 places. And then we learned that in the international system of enumeration, all the periods have 3 places. Then we learned about estimation. In estimation, we learned how to round off numbers. So to round off a number to the given rounding digit, that is 10, 100, 1000, 10,000, etc., we should check the digit to the right of the rounding digit. And then we learned about using simple brackets in mathematical calculations to make calculations easier. And then we also learned that to perform a mathematical operation involving a simple bracket, we first do the mathematical operation inside the bracket and then only proceed further. Then we learned about Roman numerals and we learned a few set of rules that we have to use to form Roman numerals. So children, I hope you are clear with all the concepts you learned in this chapter. So please go through all the concepts once again, and today you have to go through the topic more about special numbers once again. Then in page number 14, you have this exercise called Try This. Just have a look at it and you can note down your answers to the exercise in your notebook. Then there is an activity given in the same page, Maths Lab activity to generate the multiplication table of any 2-digit numbers. Have a look at it and do try to do this activity with the help of your parents. Now, next you have Speed Maths, a box named Speed Maths in page number 15, which is about the easy way to multiply a number by 11. Go through it please. And then you have the heading Maths Around Us, about which we have already discussed in the class. And after that, we have the heading Highlights, where it summarizes all the concepts we learned in this chapter. So children, in the next class, we will do the revision time exercise from the textbook. So here, this has got questions from all the concepts we learned in this chapter. So make sure you revise all the concepts once again and come to the next class. So that's all for today. We'll see again. Till then, bye.